If you are new to the channel, then subscribe the channel and press the bell icon for further notification.
Okay student, welcome to this new lecture. Today again I will be taking 5 questions, question number 76 onward, 76 to question number 80. Okay, then let's try to solve these questions. Okay, in question number 76, it is given in the circuit shown below the voltage and current sources are ideal. Find the voltage out across the current source in volt. So you have to find out this voltage. So for this voltage you can see here, because there is a current source, this is 5 ampere and there is nothing is there, so no current will flow in this, all the current will flow through this path only. And because it is the same path, because no current is going, so 5 ampere should flow here and then 5 ampere should come here, so only 5 ampere current will flow here, that's for sure, because this current has to be maintained because it is delivering 5 ampere, so 5 ampere should come out and should return, there is no other path. So as the current is flowing in this way, so as per our convention, this becomes plus, this becomes minus. So now we can take KVL along this path to find this voltage. Let us consider this voltage is V out plus minus, suppose this volt. If you move in this direction, so how it will be? So it will be, if you move in this direction, that is minus 10 and then again minus 2 into 5 ampere and then again you are, suppose I am moving in this direction, not necessarily you can move in this direction also. Suppose I am moving in this direction for KVL, whatever, minus 10, then again minus 2 into 5, then it is plus I will be getting, then V out is equal to 0, which implies me my V out is equal to 20 volt. That is your option D. So you can go in this way also, there is no issue for KVL, either direction you can take. In the given circuit, the current supplied by the battery in ampere is, so what will be the current supplied by the battery in ampere? This is the battery and what is the current it is supplied by it. So if you see here, you can see this is I2, this is I2. So obviously you can think of this current I1 is equal to I2 plus I2, 2I2. So simple one equation you are getting. If I take simple KCL here, this is also I2, this is also I2. So I1 becomes 2I2. This is as simple as equation you can got. Now as you need to find current only, so you can take a KVL across this path. Now if I take KVL, what will happen? This voltage I know, this resistance all I know. So current all are we can express in terms of I1, because I2 also can be expressed in terms of I1. So I will directly find I1, and that is the question, to find I1. So if I move in this direction, this is minus 1 into, again 1 into I1, sorry, minus 1 plus, because the resistance current entering through this is plus. So 1 into 1, again then plus 1 into I1, this is the current, and this is 1 into I2, and this is again 1 into I2, which is equal to 0. So now if you think here, so it will be 2I2, I2, and 2I2 is I1, so 2I1 is equal to 1 and I1 is equal to 0.5. So in 78, the portion of the circuit shown is shown if the heat generated by 5 ohm resistance is 10 calories per second. So what is heat generated? It is I square RT. So I square RT is given for across 5 ohm. This is 5 ohm. So this is your 5 ohm resistance, and this upper one is total is 10 ohm. Okay. So what is given? I square RT across this energy drawn is given. So I square RT, suppose this current is I. So it is I square into 5 into I square RT, and then T is equal to, it is given 10 calorie per second. So from here, if you can let it be there, and what they asked, then the heat generated by 4 ohm resistance, what will be the heat generated? So this I have considered I. So what will be this current? Because it is 10 ampere, it is 5 ampere, so as per current division, it is inverse ratio. The lower resistance will get higher current, it is higher resistance, so it will get lower current, it will be half of I by 2, because 10 is to 5 means 1 is to 2, 2 is to 1. So current will be in the reverse ratio. If it is I, then this current will be less, because here resistance is more. So here you have already got I by 2. So it is I square, R is here 4, again T. So they need to find this one. They have given me this one. So I can use here I square T is equal to 2. So you apply this one I square T. 4 would get cancelled. So I square into T. 2 to 4 will cancel. That is 2. So it is 2 calorie per second. The voltage and current source across the load are given V, I, and this I of 2 different. So you have known about harmonics. So this is your main fundamental voltage of frequency omega. So correspondingly you are getting fundamental current component also omega. These two are, you can say, current harmonics, third order harmonic, fifth order harmonics. But for this frequency, third order frequency and fifth order frequency, you don't have any voltage. So power will not be generated by these two. So power will, because in power you need V and I. So the same frequencies only will take care of multiplied, because this voltage cannot be multiplied with these currents. So power consumed will be between only same frequency, because I have explained in one circuit with different frequency also. You cannot take both the frequency at a time. You have to take superposition theorem. So if I apply superposition, first I will go for omega, then I will get this. Second, if I go for 3 omega, I will not have any voltage. So without voltage there will be no power. Second, if I go for 5 omega analysis, again there will be no voltage. Then again there will be no power for third and fifth. So I will get power for only first, that is fundamental frequency, that is at omega. So now it is your average power is very easy. 79 will be, this is IRMS, VRMS, Vm by root 2, VI cos theta, VI and then cos 60, the angle between these two. It will be 500 into half, that is 250 watt. In the circuit shown below, the node voltage VA. So it is a simple circuit again. Node voltage, this voltage they are asking. Okay, for this voltage, let me take nodal analysis. So this node I will make it as a reference node. And what I will do, I will make this node is also a special node. I can make this one is a node, but why I am making this one as a node? Because here I voltage I know the voltage 10 volt. So if I take this is as a node and this rest, because this branch you can take at a time and you can consider, because these two are in series, so you can consider them 10 ohm. So what will happen? You will have only one, eventually one unknown, that is only this one. This voltage this node is already reference node. I could have taken this one another node, this one another node without taking this one. But what is the advantage of taking this one? Because if I take this one, then this voltage is fixed 10 volt. And there is no need of this node, because these two can be considered as a single node. So 10 ampere, 10 ohm resistance connected between these two. So for this we need this current. So will be, what is nodal? If I consider this node, then this node becomes big dada for me. So everything will come out of it. So this current will be how much? This current V1 by 5. And because this should be coming out, but it is going in, so it is -5. And what about this? What is the current through this branch? You have this much voltage, then you have this also. So you can think it in this way also. Suppose I have V1 here, this is my, let me draw it here so that you understand from where it is coming, and this is my ground path. So this is 10 I1 voltage, and this voltage we have considered V1. So, and this current we are interested, this is 5 ohm. So you can take KVL in this path, including this V1. So it becomes a complete closed path. I will move to this and I will return through V1. So if you take simple KVL here, so you will find this answer from where it is coming. So if you see, if I take KVL here, then it is -V1, then because current is entering through this, so plus minus, so plus 5 into I1, this current that I intended to find, and then again minus 10 I1 is equal to 0, or I1 is equal to V1 plus 10 I1 by 5. So from here also you can find from how come it is coming. So it is simple KVL only. So it is V1 plus 10 I1 divided by 5. Or you can remember also, if I move in this direction, so what is the voltage across this? For current, what we calculate, the voltage across is divided by resistance. So what is this side voltage is, because this side plus terminal is connected, so this side voltage is V1 minus this side voltage is minus 10 I1, and then divided by resistance. So you can think of this way also, that will give you also same answer. So this current, and then again this if you think what is the resistance, it is 10. What is voltage across? Here it is plus V1, here it is 10. So V1 minus plus 10 divided by 10. Here it was V1 minus 10 I1, because minus is connected here. So voltage across this is V1 minus 10 I1. And here it will be, or you can take KVL also, drawing this type of circuit you can easily do it. Or V1 minus 10 divided by 10, that is equal to your 0. So now you can easily, I think you can do it, because this branch is and I1 you have already a relation, so you put I1 is equal to here, then you can directly find it. If you put I1 value here, if you finally do it, at last stage you will find it is 7 by 10 is equal to 8, which will implies your VA, or suppose this is VA. So VA, sorry, this is VA. So you can consider it is VA. Change all this to VA. So this implies your VA will be equal to 11.428.
If you like the video, then press the like button and please give your valuable comments in the comment section.